The fourth planet from the Sun, Mars, is much smaller than the Earth and has only 1/10 of the Earth's mass. The distinctive red color is due to iron oxide in the soil. Mars has a much thinner atmosphere than Venus or the Earth, and clouds are not very common. The white patches here are clouds which formed when water vapor rose to pass over high mountains. The largest mountain on Mars is a huge extinct volcano called Olympus Mons. The base of the mountain is almost the size of France, and it's 3 times the height of Mount Everest. The cliff along the base is 2 kilometers high. Photographs taken of the surface indicate that Mars has been eroded at some time in the past by liquid water. Here, a flash flood has obliterated all features except a number of craters. Smaller craters are due to impacts after the flood.
The big question remains unanswered. Has life ever evolved on Mars?
Europe has declared, in a way, its clear priorities for exploration of Mars, and they relate directly to the finding of evidence of past life, potential for future life, and indeed, perhaps in an ideal discovery, the one we really want to make, evidence of present life.
Since the first telescope observations of Mars in the early 1600s, scientists have suspected that Mars is more Earth-like than any other planet. To confirm this, the European Space Agency launched in 2003 the Mars Express mission, and the first real proof arrived. But the main quest remains to find traces of water in any form.
You look at the surface of Mars, it really looks as if there's been liquid. In many places on the surface, you see evidence of things that look like rivers, of structures that you would see in a dried up stream bed. But frustratingly, you don't see the water.
If we can determine why Martian water disappeared in the past, we may learn more about whether a similar fate one day awaits the oceans of Earth. But Mars Express made other important discoveries. Methane, a gas associated with geological or biological activity on Earth. Impressive as they may be, Mount Olympus and the rest of the Martian volcanoes have long been inactive. So if it isn't geology, what is producing the methane on Mars?
If there is organic activity on Mars, it almost certainly has to be below the surface. How far below the surface? Well, there's a limit to how far we can dig, but we can go down 1 or 2 meters if we put the effort in to develop the capability to do that.
This is the philosophy behind ExoMars, a joint ESA-NASA future mission which envisages the launch of a Mars orbiter and a rover to provide more answers on what lies above, but especially beneath, the red planet's surface. Apart from being a prime candidate for future manned exploration, digging into the past, present, and future of Mars can also help us understand the evolution of life on Earth and identify potential new homes for mankind in the distant future.
The Mars Reconnaissance Orbiter has seen many places on the planet. One of the most interesting is one of the Great Canyon systems on Mars. This is a branch of that canyon system called Candor Chasma. You can see the tortured ground that is there, the layers, the many buttes and mesas that poke up above this. The scale of these things is such that we're looking across a couple of miles of territory. There is no vertical exaggeration in the stereo image made by taking images at separate times on separate orbits. Some of these buttes extend up a football field in size. Fault systems that were produced by earthquakes, in this case Marsquakes, give us clues as to whether this is material that was eroded away or actually whether it was deposited and then eroded later. One of the questions we have about Mars is where we see the effects of water on its surface. How did that water get there? It may have been different in different places. Did it erupt from underground, at springs, for instance? Or did it fall from the sky in rainfall? And it may have been associated with events like impact craters. One of those impact craters is Mojave Crater. As you can see, water ponded on the terraces, and then it overflowed and ran down to the next terrace. If you look at the rim of the crater, you see channels that run right up to the top. So these aren't springs, this must have been rainfall that carved this part of the planet. One of the early images taken by the Mars Reconnaissance Orbiter was of Victoria Crater in order to help the Opportunity rover figure out which way to move around the crater as it looked for a way to get down inside. Here you see that image taken from 180 miles above the surface of Mars. We're going to use that image to zoom in and see what it would look like from the rover's point of view if it were on the edge of the crater looking out over it, and then match that with an image that was actually taken from the rover Opportunity on the Mars surface.
Scientists realized these plains of Gusev Crater didn't have the water story everyone was looking for, and they wondered, could the Columbia Hills harbor the pot of gold?
They basically just gave us the keys for a couple months and said, get the rover to the Columbia Hills by Sol 160.
As we started to find the water story in the Columbia Hills. We have made very important discoveries within the rocks. Mineral types that we believe that formed in water, and both Spirit and Opportunity have done that through their mission. 2 years into the mission, so well past the prime mission, the right front wheel stopped working, and the wheel doesn't spin. So when we drive backwards, dragging that wheel, and it would cut a furrow. And so it actually turned out to be yet another scientific instrument or scientific investigation, because it now trenched as we would drive along, revealing what's just beneath the surface.
One thing that we seem to be finding almost anywhere we're digging this trench are these widespread deposits of various kinds of salts and minerals. They look this brilliant white or yellow in the color images, and that's because they're either sulfur or silica or salts of various kinds. And the really important thing about these minerals, and salts in particular, is that the only way they form is with water. So the fact that we're finding these salts is real evidence that there was hot water over a very widespread area, not just little isolated pockets. Mars really could have been a place that supported life.
In April of 2009, we were driving on the west side of home plate after we were unsuccessful in trying to go other ways around home plate. And the rover broke through what I would describe as a perfectly camouflaged tiger trap. So we stopped, and we did a very ambitious ground test campaign where we built a sandbox in the ground, used one of our engineering rovers, and experimented with techniques to try to get the rover unstuck. The reality is it's very difficult with just a 5-wheel rover to get it unstuck from this difficult predicament.
Very, very close to it.
We have a very ambitious stationary science campaign for the rover. There's a lot of lander science that one can do, and we plan to do that with Spirit. Opportunity was blessed with good fortune right from Sol 1, right from the first day. Because when we landed and we took that first images from the lander, we looked around, we were in this tiny little crater, we call it Eagle Crater, but there was exposed bedrock.
It was just this flat sand fields with a little curb of outcrop rock. Everybody was stunned.
We found bedrock. We found rock attached to the planet.
Next, Opportunity set a course for Endurance Crater. Engineers on Earth had to teach her to drive downhill, taking grindings along the way.
We knew 6 kilometers to the south was this giant crater called Victoria. Wow, 6 kilometers away. Could we get there?
Take this rover, kind of laboriously work our way through this huge maze of ripples to get ourselves south to the scientific promised land.
It's a half-mile diameter crater, about 800 meters. And because it's so large, it also means it's deeper than anything we've examined before. And so going down into the crater is kind of like going back in time. It allows us to examine geology that normally would be buried, but it would be very old geology. So it's like reading the Martian history book and getting a few more chapters in. So we've picked a spot where there are gentle slopes, there's a good footing for the rover's mobility system, and so we think it's safe not only to go in, but to come back out again. Opportunity has crossed almost 26 kilometers of odometry, and it's still in very good health. That's amazing after 7 years.
Opportunities in kind of a desert trek mode ever since we've left Victoria. Opportunity now is located at Santa Maria Crater.
It's one of the freshest craters that either rover has had a chance to explore. And there's also evidence of some hydrated sulfate minerals around the southeast corner of this crater.
They can only form when there's been water along for a really long period of time.
The next big adventure for that rover, and that's to get to Endeavour Crater, which is a giant crater that's still some 6 kilometers away from where the rover is right now.
We're trying to do a balance of driving as fast as we can, but making sure we don't miss anything critical as we drive. Endeavour is such a large crater, we might start seeing rocks ejected from Endeavour well before we get there.
We were simply driving along, we looked at the images that we had acquired, and we saw this dark spot out, and we said, well, whoa, that's different. Let's go there. And so we drive to it and investigate it.
Amazingly, we found, 3 or 4 of these meteorites, gigantic chunks of iron just sitting on the surface of Mars.
2 of them are they have what we call a cavernous weathering, where the interiors look like they've been eaten out, which is quite common here on the Earth when you have water that infuses and weathers out the interior.
Then just recently we found another large rock that was completely different called Marquette Island.
We've gotten rid of the weathering rind and measured its composition, and it's a very olivine-rich basalt. So it's a rock, and it has big crystals, so it probably cooled slowly at some depth.
And this was some other piece of Mars that had probably gotten blasted off from a meteorite strike. So, here's a whole other piece of the planet somewhere that they can analyze and try to figure out how it fits into the whole geological picture. I think everybody's stunned that the rovers are still going. I mean, it's been repeated, so many times. Well, this was a 90-day mission, that we're 6 years into a 90-day mission.
It's exploration in its truest form. That's what's so wonderful about having a rover. If you don't like where you are, go out and go someplace else.
Well, since the beginning when we landed, we've been studying the soil that we've landed upon, and it's quite interesting and I think very unusual. From the first look at the footpad under the lander, we could see that we broke through a very thin crust on the surface. So the soil is definitely layered in the sense that the very top surface layer is crusted, and then underneath is some looser soil. And of course, when we looked under the lander, we saw, holy cow, the exposed hard layer that most people suspect is ice, but we have yet to verify that. And then we've been using our arm to dig into a part of our terrain called Dodo, and we've been digging a trench, and we have a picture of the latest view of the trench, and clearly you can see that there's some white material exposed in the trench. There's a debate as to whether this might be a salty layer or just an ice layer, but definitely it extends right beneath the surface, just about 5 centimeters or 2 inches down below the surface.
Phoenix had finished its prime mission and kind of achieved all the things we said we were going to do when we landed. We got all the analysis from TIGA, we've confirmed water on the surface, we've characterized the soil properties, we've delivered a number of different samples to the instruments, taken lots of images. We kind of knew we had achieved what we came there to do.
Mars has 2 small moons. This is Phobos, a heavily cratered body around 25 kilometers across. It's not spherical, but oblong in shape, and it keeps the same face to Mars at all times. Deimos, the other moon of Mars, is even smaller, being about 15 kilometers long. Both moons are believed to be asteroids that were captured by Mars several billion years ago. They probably came from the large belt of asteroids that lies between Mars and the next planet from the Sun, Jupiter.